Thanks so much. It's a pleasure to be here today. Really looking forward to talking to you guys about the evolution of performance engineering. So that's where we're going to start, and then I'll get into why it should be an organization-wide priority, how we can help address the scalability challenge, and some steps to consider for implementing a standardized performance engineering approach. 20 years ago, technology seemed complex, but we had no idea the explosion of technology that was about to happen. It used to be that we had a few standardized frameworks that we used for development of applications and websites, and just a couple deployment models. And then over time, we came to love virtualization, mobile application development frameworks, and APIs and Agile has just taken off, and so has new architectures based around microservices and SaaS. And here we are today talking about automation and containers and Kubernetes and how we can do everything now in the cloud. So that's a lot of change over a short period of time that all companies are trying to keep up with, because now all companies are really software companies. And so in order to keep up with this complexity and not lose speed, in fact, we have to move faster than ever in this more elastic environment. We need to keep pace in terms of our performance testing. And there's a lot of things to consider about that I'm going to talk about today. For development teams, they're trying to keep up with all of the enterprise requirements that cover everything from AI, cloud-first initiatives, their digital transformation, DevOps, virtualization, SaaS security. And for performance engineering, they need to keep pace with all of these initiatives and make sure they're hitting the highest risk areas that they need to touch so that what they're bringing to market is reliable. And how do they do this? I mean, these are a lot of competing demands and the stakes are very high. On top of that, we have all these dichotomous application and deployment models now, and they require a new way to test. So waterfall and Agile and DevOps, most enterprises have a mix. The customers I've talked to, they still need to maintain certain projects under a waterfall environment where they're doing primarily manual testing over the course of a few weeks for their performance testing on their monolithic applications. And that's something that they're going to maintain for a while. But as they move to Agile and DevOps, the process for performance testing over the course of a few weeks doesn't really scale when you have releases going out minutes, hours, days, weeks, and months at a time. So they need to really consider how they can scale their approach to keep up with that DevOps environment, to be able to test microservices as they come up, to be able to scale their performance engineering as those microservices touch many different applications and ultimately become monolithic in themselves. And all this on top of, hybrid environments. Some of this is on-prem, some of it's going to be in the cloud. And they need to be able to manage both deployment models and run their testing requirements regardless of where those applications live. And all this is done typically and traditionally by a centralized center of excellence team for performance engineering. And what's happening with DevOps is that a lot of the team is becoming more distributed throughout the organization. So instead of having one group who has the expertise, they now need to be able to move to more of a self-service, self-managed performance testing approach that not only scales in terms of frequency, but also in terms of skills across the organization. So we did a survey with Sogeti, and it's called the State of Performance Engineering. You can find it on the Tricentis website. And the results of our survey show that businesses have a variety of approaches to organizing their performance testing. 37% predominantly use a specialized quality engineering team. About a third have a collaborative approach, 17% work autonomously, and 15% outsource their work. Who undertakes the performance testing for these companies seems to be in flux and likely to change in the next few years. We believe there are two tectonic movements affecting performance testing, the adoption of agile development practices, and the move to DevOps. As people are moving to these approaches, they're expected to be more self-directed and work as peers and teams and participate together and have a higher rate of collaboration. And that means it's not just the performance engineers participating in the performance testing process and in the results. It's all different types of DevOps and operations and development and engineering teams that go beyond just performance testing. But scale isn't just about load. So when you hear the word scale and performance together, you probably think about putting intense load on an application to make sure it can handle hundreds of thousands of concurrent users under various scenarios. And that's, of course, critical in performance testing. But with DevOps, the meaning of scale shifts a bit. How does performance testing that typically takes weeks keep pace with releases that take hours? How can you go from just a couple of tests per month to hundreds and still give enterprises the credibility and predictability and confidence that they're used to? So that's also scale. Poor performance isn't just about load either. And now it affects your business. If an application doesn't load within 4 seconds, you're likely to lose 40% of your customers, and they're unlikely to return. And so that has real negative impact on the business from a brand perspective, from a competitive perspective, and a value. And it's very difficult to get those customers back. And this also counts for internal employee applications that help run enterprises' business. If they're not going to have a good experience using their applications, the adoption of those applications are going to be less likely, and the satisfaction of the employees are going to go down. So having performance built into development is a competitive advantage. And performance testing, this is the survey that we did with Capgemini, and it's becoming an organization-wide priority. Over 72% are saying that performance goals and metrics are shared with the business users in their organization. 69% say that application performance is an integral part of their brand equity and DNA as a company. 60% say that customer-facing application performance is a driving force to ensure revenue, competitive advantage, and customer acquisition and retention. 70% say internal application performance is a driving force to ensure employee efficiency and productivity. And 60% say performance engineering accountability is at the project level only. So that last data point is interesting because what it means is while the business is equipped to say this is our plan and this is an important priority for us to make performance, the outcomes and the SLOs part of what we expect going into our planning, some of the teams are still catching up. So today we'll talk more about how we can help that happen. So embedded into a DevOps initiative, a low latency core team of specialist performance engineers can help multiply development teams concurrently to focus on performance. They can help infuse a good engineering practice through multiple teams. These teams help with conducting things that are outside their direct ownership, so from point assessment to continuous integration. What I like about this quote is that it talks to the point that in a microservices architected application and in a distributed computing world, one bug and one bottleneck in a microservice can have a multiplier effect on your system because you have applications, maybe the infrastructure is located in Europe, but the front end of the application is being accessed in California. How do you know when those pieces and parts interact where the bottleneck will be? So really, we need to go shift left and make sure that we're bringing in the development and they're able to account for, at the API level, what kind of considerations do they need to make if an API is going to be hit, and what endpoint considerations do they need to make early in the design phase, so that as the microservices application is becoming a monolith, it's being built from the ground up in a way that's going to perform. So what's the answer? Is to scale the performance engineering approach and not the people.